All right, so another great question that's come up on the forum, and there's been a lot of discussion about the mutability of pathogens, the ability of pathogens to evolve and evade the immune system and immune response. And I thought this was a beautifully simple question, which is just simply, well, why can't our bodies evolve and change at the same pace and as rapidly as the pathogens to just keep out every new infection? Go ahead, Mary. I know you want to.
Yes, you may.
And we can all speak. They do. They absolutely do. Obviously, the rates may be a bit different, but the beautiful configuration of our immune system cells is that they have this ability, and it's not all genetically encoded. It's something that arises after a cell has sensed its antigen, something that it recognizes, and then those proteins can further develop some sequence diversity. And so it's really almost an unlimited array of receptors that can detect pathogens. It's pretty remarkable.
Yeah. And I think it's important to note that there's sort of two ways in which the body changes, and the body creates a huge diversity of initial starting points, basically initial things to detect possible invaders, right? But also has a mechanism for getting better at detecting and binding onto antigens once a certain type of invader has been detected. So both in anticipation of an assault by foreign agents, as well as in response to an infection itself, the body changes and evolves in a sense.
And hence vaccination can take advantage of this because it means that you don't have to first have seen the antigen.
Right.
You can sort of prime yourself a bit to have seen something similar and then have that maturation step.
Well, I think it's really interesting that we have this notion of the virus is rapidly evolving. And somehow we think, well, our genomes are fixed and we can't evolve. But there's this process that Mary's talking about of incredibly fast evolution that we think of, I think of at least, as somatic evolution within the body. So our genomes are staying the same for our lifetime, but within us, individual cells are evolving so rapidly and they can keep up with this thing. And this process is amazing. It's in fact the co-evolutionary process in the case of us mammals is the virus against this somatic evolution in our body. It's a fantastic process. It's just gorgeous.
Yes, and it's a process that has been conferred on us by viruses, and some of the endogenous and mobile elements in the body give us the ability to change those proteins quickly.
We must also remember that there's the other side to this as well, that the viruses are often, when they do kill individuals, and I'm thinking wildlife populations now, they will select out those individuals that are more susceptible or more vulnerable, as it were, so leaving the remaining ones to evolve and to become more resistant. So if we look back at some of these emerging diseases, they can come, when they come into wildlife, they can have massive mortality, but the second and third time they come in, the impact is much less. That's probably because they're selecting the hosts who are more resistant.
And we're experiencing an example of that right now with the invasion of white nose syndrome in bats in North America. And there's been a lot of active discussion and hypothesis about how bat populations might respond to this. Yes. One of which has been a hypothesis that we'll be left with bats that are inherently more resistant. There's been also some interesting new research that I saw presented this summer that it had nothing to do with the actual inherent susceptibility of the bats, but just about their social organization. Yes. And then in fact what's being left behind are bats that have smaller aggregations so that the colony itself is less susceptible because there's less introduction through the course of the year and less transmission within the context of the colony.
I think that's really interesting.
Selecting for behavior.
Yeah. Yeah, so it's selecting for a social organization almost in some sense, right?